So before we start the chapter P block elements, let me briefly walk you through how to access the revision notes and test in Clay6 website. If you go to clay6.com and click on practice, we have different packages available here. Since we are going to discuss about so in test series, we are having physics, chemistry, biology, and NEET full test. And each subject, if you click, you will have test for chapter wise, and each chapter has n number of tests, and the total number of tests in it depends upon the importance of the chapter, or we can say weightage of the chapter. And at the top we have the revision notes. That is, if you click on the revision notes, it opens in a new tab. So in the starting, or let us learn the chapter P block elements. So when we talk about P block elements, the P block elements is the elements which will be belonging to the, or P block elements are present in the extreme right of the periodic table. And the general electronic configuration is NS2, NP126. But when we categorize the elements in P block, it includes solid, liquids, and gases. The elements of this group are basically metals, non-metals, and period in a periodic table. Non-metallic character basically indicates the electrons moving down the state. If we say the lower oxidation state becomes more stable due to, it becomes more stable due to inert pair effect. It becomes stable due to inert pair effect. So when we say what are all the elements which is belonging to the P block elements, that is, the boron group are the chemical elements in group 13 of the periodic table, which we call it, which we have it as boron, aluminium, gallium, indium, helium. All these elements are belonging to the P block elements. And the elements belonging to group 13 to group 18 of the periodic table, we call it as P block elements. And the most important factor is when we say as the, as we are going or moving down the group, the lower oxidation state becomes stable due to inert pair effect. So we should know what is inert pair effect. So when we say inert pair effect, it is nothing but reluctance in the participation of your s electrons in bond formation due to poor shielding effect by the d and f orbital, and because of this the electrons are tightly bounded. So when we say it is differing from other elements or first member, there are certain factors based on which it will differ from other elements. So when we say the atomic radii, how does it differ, or what is the property of the atomic radii? based on the comparing with the other elements. So when we say atomic radii and ionic radii, if we compare group 11 with group 13, then we could conclude that group 13 is smaller because of the increased nuclear charge. So when we say out of R, Be and B, boron will be smaller. So down the group, your size will increase because nuclear charge is decreasing. And why we say size is increasing? It is because of the addition of a new shell. And the factors when we are talking about, we are having different compounds of your boron or the p block elements. So when we say that, how we are going to categorize it? So when we say the properties, not only the ionic radii or the atomic radii we need to focus, but also we should know how there is a change in the ionization energy, its electronegativity, its oxidation state. So how does it differ from other elements or other group? If we are comparing the ionization energy of group 13 and group 2, we can say that ionization energy of group 13 is more because of their small size and increased nuclear charge. Because of their small size and increased nuclear charge, we can say that ionization energy of group 13 is high. But actually when we compare, group 2 will have high ionization energy than group 13 because of the completely filled s orbital in your group 2 elements. And when we are talking about electronegativity, more electronegative, or if we compare once again the electronegativity of group 13 with group 2, they are more electronegative because of your increased nuclear charge. And that alone is not the factor, or we can say just because their electronegative is more, it will decrease, but the expected, as general we can say boron, aluminium, so the order goes on. And that is because of the poor shielding effect. It is because of the poor shielding effect. So immediately we can land up when we are talking about electronegativity, how does the electropositive value changes, or what happens to the electropositive character when we compare group 2. They will be, they are less electropositive due to their increased nuclear charge. Hence, we could conclude that the size increases, therefore, metallic character increases. And when we talk about oxidation state is totally going to depend upon the electronic configuration. And as their electronic configuration is basically ns2np, oxidation state shown by them are +3 and +1. But still, if you focus on the chapter, you can say that one exceptional you will have, that boron will show exceptional behavior because of its small size and high ionization energy, because it will have difficulty in losing electrons, and hence it will always have the tendency of forming the covalent bond. It has the tendency of forming covalent bond. And yes, these are all the physical properties which we are talking. But when we go deep into the chemical properties, that is, out of all the elements of this group, when we talk, boron is a non-reactive element because of its small size, as it will have high ionization energy. Because of its small size, it will have high ionization energy. So when we are talking about the reactivity, as we have said, boron is non-reactive. So when we talk about reactivity, the order goes like this: boron, aluminium, and gallium, indium, thallium, and so on. So when we talk about reactivity, it increases or we can say it has high ionization energy. So reactivity increases down the group. It increases down the group. So if you conclude from this, the questions they may ask, which is least reactive or which is most reactive, based on it, we could conclude that boron is the least reactive element. And why it is least reactive? Because of its small size and high ionization energy. Because of its small size and high ionization energy, it is least reactive, and thallium is most reactive because of its low ionization energy. And yes, of course, when we are talking about aluminum, when it is reacting initially, it keeps reacting. But after some time, a layer of its oxide is formed over its surface, and this layer will prevent it from further reacting. So it becomes passive after some time. Among the given list of element, which element becomes passive after some time? It is none other than aluminium, because after some time a layer of its oxide will get formed and it will stop reacting, or you can say it further reaction stops for aluminium, saying that it becomes passive in nature. And most of the compound of this group are basically electron deficient. That means what? Electron deficient indicates that their octet rule or their octet is not complete, or it does not satisfy the octet rule. Hence, they start behaving as a Lewis acid. They start behaving as a Lewis acid. And next, when we are talking about different boron compounds, it's important to note that there are different boron compounds and we need to study about it. And when we talk about activated charcoal, it will be basically highly porous in nature, because of which it is used for absorbing poisonous gases. And when we talk about the compounds, that is, first one we can say it as borax. What is borax? Borax, it is a white crystalline solid and it will dissolve in, it will stop or it will dissolve in water to give an alkaline solution. It will dissolve in water to give alkaline solution. So boron compounds, the formula for borax is Na2B4 dot 10, sorry, Na2B4O7 dot 10 H2O. So it is a crystalline, it is a white crystalline, and it is basically prepared from calcium ore. Borax is basically prepared from calcium ore, and in this ore it is made to react with sodium carbonate. In this it will be made to, the calcium ore is made to react with sodium carbonate. That is, we can say Ca2B6O11 plus Na2CO3 will give you CaCO3 plus Na2B4O7 plus NaBO2. So we are getting Na2B4O7. This is what we call it as borax. And this one, it is calcium ore, or it is also called as colemanite ore. Colemanite ore, and this is sodium carbonate, this is calcium carbonate, borax, and sodium metaborate. Sodium metaborate. And we can say, when we are talking about the properties, it is a white crystalline solid, as we have already seen, and on heating it will lose water of crystallization and form Na2B4O7. On further heating it will give white transparent liquid, which further on cooling will give white transparent bed. And this is made to react with different types of salt. This bed is made to react with different type of salt, and when it is reacting it will give different color with different metals. When it is reacting with different metal it forms different color. And the most important thing is what are all the places we use borax. It is being used as making enamel for pottery. It is used in candle making. It is being added to soaps because of its antiseptic property. Since it has antiseptic properties, it is being added to soap, and it is used in optical glass. And next, when we talk about one more compounds, that is boron compounds, it is orthoboric acid. Orthoboric acid, H3BO3, or it can also be written as BaBOH thrice. So how does it, or how it is being prepared? Boric acid or orthoboric acid is being prepared from borax. That is, when borax is reacting with hydrochloric acid, it gives us boric acid plus sodium chloride. The reaction can be Na2B4O7 dot 10H2O. This can be made to react with sodium, sorry, hydrochloric acid, that is HCl plus H2O. It will give us H3BO3 plus NaCl, H3BO3 plus NaCl. And it is a white crystalline solid with a soapy touch, which is sparingly soluble in cold water, but it is soluble in hot water. And it will have the tendency of forming metaboric acid at 373 Kelvin. It has the tendency of forming metaboric acid at 373 Kelvin. And another boron compound which we can talk about is boron hydrides. Boron hydrides. The molecular formula, you can say general formula, or the basic is B2H6. And this one is diboron, but boron hydride, general formula, it can take up as BnH2n plus 4. BnH2n plus 4. And it is prepared by reacting sodium boron hydride with iodine. It is prepared by reacting sodium boron hydride with iodine, and it is a colorless and toxic gas. Basically, it has the tendency of catching fire spontaneously, and yes, it is stable at low temperature, and also it is being easily hydrolyzed. It will have the tendency of being easily hydrolyzed. So this was about the boron family or boron compounds. Next, we can talk about the carbon, silicon, germanium, and lead. These are all not affected by water, but tin has the, or it will have the tendency of decompose steam to form dioxide and dihydrogen salt. And what happens when we heat the boric acid? It will have, on heating the boric acid, it will decompose to form metaboric acid. And as your temperature is increasing, it still decomposes. It can form tetraboric acid at 435 Kelvin and boron trioxide at red heat. And carbon is going to, when we talk about carbon, carbon differs from rest of the member of its group due to its smaller size, high electronegativity, higher ionization enthalpy, and unavailability of the orbitals. So basically, when we talk about carbon dioxide, in carbon dioxide, carbon atom is basically sp hybridized, because the two sp hybridized orbitals are oriented at an angle of 180 degree, giving it a linear shape. So when we talk about linear shape or carbon, silicon, germanium, all these things, they are considered to be group 14 elements. And when we say group 14 elements, that is carbon, silicon, germanium, tin, lead, all these elements are going to belong to the category of your group 14 elements. And when we talk about the atomic size, that is how it is going to differ. As we said, it is having a different property, or carbon differs from other elements in different criteria. So when we compare the size with group 13, then size of group 13 element is actually bigger than group 14, because group 14 elements are small due to increased nuclear charge. Hence, we can conclude that when we are going, or when we move down the group, as we move down, size increases as each time a new shell is being added to it. Size increases as each time a new shell is being added. And when we talk about ionization energy, we should know that it is the amount of energy which is required to remove electron from last shell of atom, and when it is in gaseous state. So we know ionization energy is inversely proportional to size. Ionization energy is inversely proportional to size. Therefore, ionization of group 14 will be higher than group 13 because of its small size. So we can say that along the group, ionization decreases because size increases. Hence, if you are looking at the trend, it should be in this order: carbon, silicon, germanium, tin, and lead. So as we move from tin to lead, the ionization energy increases due to poor shielding effect of 4f orbitals in lead. And melting point or boiling point. The boiling point of group 14 is basically higher than group 13, as they are going to form covalent bond because of their small size. And in melting point, as you are moving down the group, melting and boiling point decreases due to increase in size, and bond formed will not be so strong. Bond formed will not be so strong. Hence, learning a chapter or learning about any element or compound, it is important that we focus on the properties, not only just knowing, but we should be able to compare the properties, which is increasing, which is decreasing, whether in group it is increasing or decreasing. These are all properties will be helpful in attempting the question in the exam. Hence, it is very, very important to learn about the properties, how it varies depending upon the criteria. And when we talk about the group 14 oxidation state, this group will have the tendency of showing an oxidation state of +4 and +2. So carbon, because of that is because of high ionization energy, it always supports, or it is always in favor of sharing electrons. So it shows an oxidation state of +4. In the same way, the commonly oxidation state is +4, but lead alone will show an oxidation state of +2 because of the inert pair effect. And all these elements has special property, that is, if suppose they are present in +2 oxidation state, they have the tendency of acting as a reducing agent. They have the tendency of acting as a reducing agent. And when we talk about the oxides, when we talk about the oxides, or we could say, how does these element reacts with oxygen? So when they are non-reactive, but reactivity will keep on increasing down the group because of their decrease in ionization energy. So when we say reactivity towards oxygen, they are forming two oxides, that is monooxides and dioxides. And out of them, we can say when they are forming oxides, like monooxides, we can take example as CO, SiO, GeO, and many more. Dioxides, when we say CO2, SiO2, and etc. So out of them, when we consider CO, it is neutral in nature. SiO, it is not so stable. So each one has a different tendency or different property, or we can say different way of reacting. But if you compare all these elements, among it, CO is strongest reducing agent because it has the tendency or it has the ability of accepting oxygen, and it will form stable oxide, that is nothing but carbon dioxide. And we all know the solid form of carbon dioxide is called as dry ice, and the commercial name of dry ice is dry cold. And out of the elements of your monooxide and dioxide, PbO2, this is considered to be the strongest oxidizing agent. So if the question being asked is in your group 14, which is considered as strongest oxidizing agent and which is strongest reducing agent. So we can say CO is our strongest reducing agent and PbO2 is strongest oxidizing agent. So each element has its own criteria of reacting. For example, if we take the reaction of group 14 with water, it is a well-known fact that it has the tendency of forming a hydroxide. Carbon does not react with water. Tin will react with steam. They form SnO2. And your lead, Pb, they do not have the formation or they will not react with water because due to formation of protective layer of oxide on it. They have the tendency of forming protective layer of oxide on it. And when we talk about how does these element reacts with halogen, it's very simple that when it is reacting with halogens, halides are formed. So these are all the basic properties, and the most important part is what are all the allotropes of carbon. What are all the allotropes of carbon? When we say allotropes of carbon, allotropes are nothing but, or they are the different form of element having same physical property, but they will have different chemical properties. I repeat, they are the different forms of element having same physical property but different chemical properties. So allotropes of carbon, we are having two, that is crystalline form and amorphous form. Crystalline form, diamond, graphite, fluorescence. Amorphous form, we will have coke, charcoal, etc. Or here we have diamond, graphite, and fluorescence. So diamond, we all know each carbon is attached to 4 carbon atom, giving rise to a compact 3-dimensional structures. Diamond has 3-dimensional structure, but it is very compact. Graphite, in this carbon is basically sp2 hybridized, and each carbon is covalently attached to the other carbon, which will give hexagonal ring. To graphite, it gives hexagonal ring, which in general we know that graphite has sheet-like structure. In general, we know that graphite has sheet-like structure. And when we talk about uses of diamond and graphite, we all know diamond is the hardest substance and it is used as a cutting tool. It is a bad conductor of electricity because it does not have any free electrons. Graphite, it has soft structure because of its van der Waals forces in it. And yes, it is being used as a lubricant. It is being used as a lubricant. And when we are talking about the different compounds, or we have carbon monoxide. How is it being prepared? carbon monoxide is prepared from incomplete combustion of carbon. It is prepared by incomplete combustion of carbon, and there may be many more commercial or different laboratory method of preparing carbon monoxide. But commercial preparation is heating coke with water at high temperature. It is heating coke with water at high temperature. It is being used to produce, and this is the method which is used for commercial preparation. It is a method which is being used for commercial preparation. It is a colorless and odorless, and yes, of course, it is insoluble in water, but it is very highly toxic in nature, as it will combine with hemoglobin to form defective complex, And next one, when we talk is, it is about carbon dioxide. Carbon dioxide is prepared from complete combustion of carbon and carbon containing fuels in excess of air. Carbon plus oxygen, it gives us carbon dioxide, or even we can use methane plus oxygen will give carbon dioxide plus water. Once again, it is a colorless and odorless. It is soluble in water, and of course, it is a non-supporter of combustion. It is non-supporter of combustion, and it will combine with water to form carbonic acid, which we say it as a weak dibasic acid. And next one is silicon dioxide. Silicon dioxide is the element, or we can say it is present about 95% of the earth crust is made up of silica and silicates. About 95% of the earth crust is made up of silica and silicates, and silicon dioxide is commonly called as silica, which will occur in different forms like quartz, cristobalite, tridymite, and these forms are basically interconvertible at suitable temperature. The most important factor is it is interconvertible at suitable temperature. And silicon dioxide, it is covalent in nature with three-dimensional network of solid. It is covalent in nature with three-dimensional network of solid. And silicon atom is actually covalently bonded in tetrahedral manner to form 4 oxygen atoms. 4 oxygen atoms, and silica is in normal form is almost non-reactive because of high bond enthalpy between Si and O2. It's a high bond enthalpy between your SiO2. And silicon dioxide, the most high usages, it is being used as a catalyst in petroleum industry. It is used in petroleum industry. And the next one is silicones. They are nothing but the synthetic organosilicon compounds, which is going to contain, or we can say the general formula or repeated R2 SiO n times. This will be held by their linkage. It is SiO(Si). By this linkage formation, it is being formed. So we could say that the method which is used for preparing silicones are the methyl chloride will react with silicone in presence of copper at a temperature of 573 Kelvin. And as a result, we can say we get different types of methyl substituted chlorosilane of the different group. And suppose if we are trying to say what are all the properties, means it is a silicones when it is being formed. I said it is a structure. So when you are having short chain, it is oily liquid in nature. When it is medium chain, it is viscous or oily or jelly-like nature. And long chain means it has rubbery elastomers and resins. And when we talk about the properties, how it reacts, they are chemically inert and it is resistant to oxidation and thermal decomposition. It is inert and it is resistant to oxidation and thermal decomposition. But they are basically being used in making waterproof papers or making wool, or it is being used in textile by coating them with thin film of silicones. And yes, they are used as an electric insulators. And also they have the tendency of being used as a lubricants at high as well as at low temperature. And the next one is our zeolites. So zeolites is nothing but it is the zeolites is being used as a catalyst in petrochemical industries. And silicates, their basic structural units, we could say that it is SiO4 minus, and the important man-made silicates which we are using in our day-to-day life is glass and cement. Glass and cement. And when we are talking about different properties of the p block elements or your boron or group, that means we should remember that boron 10 isotope is being used in nuclear industry as well as protecting shield and control rods. And fluorescence are made by heating of graphite in an electric arc in the presence of inert gases such as helium or argon. So it's very important to note that how we are reaching to a conclusion by learning the concept and properties. This is what we had about P block elements based on our understanding. Let us try taking a test from P block elements. So when you go to the chapter wise test, if you see there are tests are assigned in a bubble form and each bubble represents a test. Green bubble means the test is already taken. Blue bubble, it indicates that it is yet to be taken, and R is a random test which you can click if you need any additional practice. So let us try taking a test from chapter P block elements. So when it's not important that we learn the concepts, but it is also important that we practice question. As many questions you practice, it will be that beneficial to you. So learn that you with the different forms of question, and when you attempt those questions as right, it will give confidence. So when we look at this question, it says NCl3 plus H2O gives NH3 plus X. And we have to find out two different reactions are given and we have to find out which one is NH3 plus HOCl and PCl3 plus H2O will give you H3PO3 plus Y, that is HCl. So our X value should be HOCl and Y value should be HCl. So the option should be A. That we will categorize by balancing the reaction. When we balance the reaction, we will be able to check that. And next, if we see question number 2, let us save that and go to next. What are all the shapes of hybridization of SO2 and SO3? So when we are talking about these shapes, what does it mean by saying shape? We all know shape and hybridization. It is very simple to calculate based on the formula, that is SO2, it is angular in shape, and the hybridization, it is your SO2 and SO3. So SO3, it is trigonal planar. SO3 is trigonal planar. Hence your hybridization should be sp2 for SO3. Hence we can say that SO2 angular hybridization for that also is sp2, and SO3 it is trigonal planar, that hybridization is also sp2. So let us click that and go to next. CaOH twice plus Cl2 gives. This reaction can be used in. This reaction is a well-known reaction for preparing the bleaching powder, and we say that as Hazen-Clever plant for the preparation of bleaching powder. If you say Hazen-Clever plant, it consists of 4 cylinders of cast iron, and each cylinder is about 2m to 3m long. And here there is a inlet which will be present in the uppermost cylinder for providing CaOH twice, and the bottom of the cylinder will have another one inlet from which they provide Cl2. And when the reaction takes place, it is CaOH twice plus Cl2 will give you CaOCl2 plus H2O, and this is a method which we can say that it is a method for preparing bleaching powder. So it is Hazen-Clever plant. Let us save that and go to next. Refer the below table. It is simple that for each element we have to calculate the oxidation number, or you can say oxidation number of sulfur, and match accordingly. We all know the formula of calculating the oxidation number. Sulfur exists in different oxidation state because of its d orbital. So when you calculate the oxidation state of each, you could say that option A will be the right option. That is, we need to calculate for H2S and find out in H2S compound what is the oxidation state of sulfur. So 2 into 1 plus your sulfur is unknown value, that will be equal to 0. So accordingly you can calculate the oxidation state of sulfur for each element and match accordingly. Let us save that and go to next. The state of hybridization of boron in BCl3. In BCl3 molecules, basically B atoms are assumed to be sp2 hybridized, or we can say sp2 hybrid orbital are being used because it will form sigma bond with your 3 chlorine atom. It will form sigma bond with 3 chlorine atom, which will give you a trigonal planar bond. And when the reaction takes place, among the given option, which one can exhibit the highest number of oxidation state? Actually, manganese or Mn will have the tendency of exhibiting highest oxidation state, that is depending on the formation of compounds with different combination. Mn has the tendency of exhibiting oxidation state of +1 to +7. Hence among the given option, manganese has the highest tendency of, or it has the capacity of exhibiting number of oxidation state. When it is forming different compounds in combination with different element, it can exist in oxidation state from +1 to +7. That is +1, +2, +3, +4, +5 till +7. Hence, our option D should be the right answer. Let us save that and go to next. The inert form of carbon. Just now we saw the inert form of carbon is, of course, it is diamond because it does not have free electrons. It is very closely packed. Save that and go to next question. Bleaching action of SO2 is due to, what is the bleaching action of? See, basically sulfur dioxide and chlorine, it is being used as a bleaching agent. However, we can say bleaching action of chlorine is based on oxidation, whereas the bleaching action of sulfur is based on the concept of reduction. Because sulfur dioxide used as a bleaching agent, it is being used as a bleaching agent, but it has the tendency of removing oxygen from the colored substance and it makes it colorless. Hence, but atmospheric oxygen will slowly occupies removed oxygen and their material will regain the color. That is a different criteria. But when you are adding sulfur dioxide as a bleaching agent, it will remove oxygen from the colored substance. Hence, we can say that it is used as a reducing agent, or we can say it is due to reduction. Let us save that and go to Hg sticks to the surface of glass when it is reacting with. Why Hg sticks to the surface of glass? It is because Hg is being oxidized by O3 to Hg2O, which will dissolve in Hg. And when it is being dissolved in, Hg, this solution will have the tendency of losing, or solution loses meniscus, and it will start sticking to the surface of the glass. Or you would be studying a concept that is called as tailing of mercury. It is a concept that is tailing of mercury, in which basically mercury is being oxidized by Hg, oxidized by O3 to Hg2O. Hence, we can say that it is being, when it will stick, when it is being oxidized by O3. Hence, our option C should be the right answer. Let us save and go to next. Select among the following one with largest size. Among the given option, say when an atom after gaining an electron becomes negative or large in size, because when it gains electron, the size increases, and here these two options are, we can say that it is rejected since it is positive. That means it is losing electrons, and this is of course an inert. So the ion which has maximum positive charge on it has the minimum size because they have the tendency of losing electrons, and the our B option is also argon, so no issues. The only element which is gaining electron here is chlorine, hence chlorine will have the largest size. Let us save that and go to next. The number of pi bonds in the product formed by passing acetylene through dilute H2SO4 containing mercuric sulfate. Acetylene, when it is undergoing hydration in presence of dilute sulfuric acid and mercuric sulfate, it forms acetaldehyde. It forms acetaldehyde, and the bond of formation of the pi in it is actually 1. Hence, we can say option B as the right answer. Let us save that and go to next. Which of the following compounds in aqueous solution will give a white precipitate acid? Which will give white precipitate acid is here. Among the given option, you can see that K plus will have is larger among all the given option, and that will react with ClO4 minus in order to give a white precipitate. In order to give white precipitate, hence our option B should be the right answer. Let us save that and go to next. Which of the following element has highest first ionization potential? They are talking about first ionization potential. So immediately it should strike that nitrogen among the given option. Nitrogen is the element which is having half-filled electronic configuration. Hence, of course, that should give us the highest first ionization potential. Let us save that and go to next. Quartz is a crystalline variety of variety of it's a well-known fact, it is of silica. So let us save that and go to next. Which of the following can be used as an antiseptic? Which of the following can be used as an antiseptic? So let us save that. We have completed all the 15 questions. Let us end the test and check how many questions we have done right and which are all wrong. So here to be wrong. It is very simple to find the explanation and its answer, and you can take the test again if you feel that you are not confident in the questions attempted. That's all we have for today's class, and if you have any questions you can available in our website, and also you can reach out to us with your questions with Clay6 Telegram chat application. But if you feel that you need help from any of the Clay6 tutor for any subject on any specific chapter to make yourself confident and ready for the exam, you can reach out to Clay6 management for one-to-one tutoring. Thank you, students. We'll catch you up tomorrow with a new chapter.